The universe is a vast expanse of mysteries and wonders that continues to fascinate scientists and space enthusiasts alike. In this video, we will explore 10 surprising curiosities about the universe, revealing some of the marvels that the cosmos holds for us. Subscribe and hit the bell to join us on this extraordinary adventure. When we look up at the night sky and spot a shooting star, we are actually witnessing a captivating celestial event known as a meteor. Shooting stars are not stars at all, they are tiny space rocks or debris, often no larger than a grain of sand or a pebble, that enter the Earth's atmosphere at high speeds. As these meteoroids collide with the Earth's atmosphere, they experience intense friction, causing them to heat up and glow brightly, creating a streak of light across the sky. This glowing streak is what we commonly refer to as a shooting star or a meteor. The technical term for this phenomenon is meteoroid, referring to the object in space before it enters the atmosphere. While the visible light display is called a meteor, most meteors burn up entirely in the atmosphere due to the extreme heat generated during their entry. This combustion is why we don't usually find meteoroids on the ground. However, occasionally, larger and more substantial meteoroids can survive the journey through the atmosphere and land on the Earth's surface. These surviving objects are known as meteorites. Meteor showers are captivating events caused by Earth passing through debris trails left behind by comets. As the debris enters the atmosphere, it results in an increased number of visible meteors, creating a breathtaking display for observers on the ground. Meteor showers and the occasional sighting of a single meteor are frequent occurrences. They remind us of the constant bombardment of space debris and provide an opportunity to marvel at the wonders of our universe right from our own backyards. So next time you spot a shooting star, remember that it's not really a star but a brilliant flash of cosmic debris gracing the Earth's atmosphere. Black holes are one of the most mysterious and enigmatic objects in the universe. Contrary to popular belief, they don't operate like cosmic vacuum cleaners, sucking everything around them. Instead, black holes exert a gravitational force so intense that not even light can escape their grasp within a certain boundary known as the event horizon. The event horizon is the critical point around a black hole beyond which nothing, not even light or any other form of electromagnetic radiation, can break free. Anything that crosses this boundary is considered trapped by the black hole's immense gravity and is destined to be pulled inexorably towards its center, a region called the singularity. However, outside the event horizon, objects can still orbit a black hole without being drawn into it. In fact, many stars and celestial bodies exist in stable orbits around supermassive black holes at the centers of galaxies, and these stars do not get consumed by the black hole. As long as they remain outside the event horizon and within their stable orbits, they can continue their regular motion. The misconception of black holes sucking everything around them likely arises from their strong gravitational influence and the idea that they are bottomless pits. In reality, black holes are not infinitely deep, nor do they actively seek out matter to consume. It's important to note that the study of black holes is a fascinating area of astrophysics. And much of their behavior remains theoretical due to the extreme conditions inside the event horizon. Nevertheless, black holes play a crucial role in shaping the cosmos, and understanding their nature continues to be a captivating pursuit for scientists and astronomers worldwide. The Sun is the heart of our solar system, and its immense size and mass make it a dominant force in shaping the cosmos around it. In fact, the Sun contains nearly 99% of all the mass in the entire solar system, with a diameter of about 1.4 million kilometers. The Sun is so large that approximately 1.3 million Earths could fit inside it. Its massive size grants it an incredibly powerful gravitational pull, holding all the planets, moons, asteroids, and other objects in our solar system in its gravitational embrace. The Sun is a seething ball of hot, glowing gas, primarily composed of hydrogen and helium, undergoing nuclear fusion at its core. This process releases an immense amount of energy in the form of light and heat, making life on Earth possible and driving the dynamics of our solar system. The planets, including Earth, revolve around the Sun in elliptical orbits, following its gravitational dictates. The Sun's gravity also governs the movement of asteroids and comets within our solar system, shaping their paths and interactions. Despite its enormous mass, the Sun is just one of billions of stars in our galaxy, the Milky Way, which itself is one of countless galaxies in the observable universe. It serves as a reminder of the vastness and diversity of the cosmos, with each star and planetary system playing a unique role in the grand tapestry of space. The Sun's energy is vital for sustaining life on Earth. Its sheer power and gravitational influence continue to inspire scientists and astronomers to study its properties and understand its role in the larger context of the universe. Gravitational waves are a fascinating phenomenon predicted by Albert Einstein's theory of general relativity. According to this theory, massive objects in the universe, such as black holes or neutron stars, can create ripples in the fabric of spacetime as they move or interact with each other. Imagine spacetime as a vast, stretchy fabric that forms the very fabric of the universe. When massive objects are in motion or experience intense gravitational forces, they cause this fabric to distort, creating gravitational waves that propagate outward like ripples on the surface of a pond when a stone is thrown in. These waves travel at the speed of light and carry energy across the cosmos. However, they are incredibly faint and challenging to detect due to their minuscule effects on the space around them. It wasn't until the 20th century that technology and scientific advancements made it possible to detect and study gravitational waves. In 2015, the Laser Interferometer Gravitational Wave Observatory, LIGO, made history by detecting gravitational waves for the first time, a monumental achievement that confirmed one of the major predictions of Einstein's theory. Gravitational wave detections have opened up a new era of astronomy called gravitational wave astronomy. They provide a unique way of observing the universe, allowing scientists to study violent cosmic events like the collision of black holes or neutron stars. By analyzing the characteristics of the detected waves, researchers can extract valuable information about the objects that created them, their masses, velocities, and distances from Earth. One fascinating fact about the Moon is that it is gradually moving away from the Earth over time. This phenomenon is known as lunar recession and occurs at a relatively slow rate. The Moon's movement away from Earth is a result of the conservation of angular momentum. As the Earth rotates, gravitational interactions between the Earth and the Moon cause a transfer of angular momentum between the two bodies. This transfer of momentum gradually slows down the Earth's rotation while propelling the Moon into a higher and more distant orbit. The rate of lunar recession is about 3.8 centimeters per year. While this might seem insignificant, it has significant implications over vast periods of time. Billions of years ago, the Moon was much closer to Earth than it is today. As it moves away, Earth's day becomes slightly longer. In the distant future, this gradual process will continue, and the Moon will continue to recede from Earth. The consequences of the Moon's movement are complex and have implications for Earth's rotation, tides, and even the potential for lunar exploration. However, on a human timescale, the changes are incredibly subtle and not immediately noticeable. One of the most surprising aspects of space is its eerie silence. Unlike the terrestrial environment, space is a near-perfect vacuum, devoid of air or any other medium to carry sound waves. As a result, there is no sound in the traditional sense that we experience on Earth. In everyday life, sound travels through the air as vibrations, which our ears detect and our brain interprets as sound. However, in the vacuum of space, there are no air molecules or particles to carry these vibrations. As a result, any sound produced in space, such as a spacecraft engine firing or an astronaut speaking, would not be audible to our ears. Despite the absence of sound, space is far from lifeless. It's a dynamic and bustling environment, with celestial bodies constantly in motion, stars being born and dying, and various cosmic phenomena shaping the universe. The silence of space adds to the mystique and wonder of the cosmos, reminding us of the vastness and otherworldly nature of the universe we explore through space exploration and astronomy. When astronauts venture into space, they communicate with each other and mission control using radio waves. These radio signals can travel through the vacuum of space, allowing for communication over vast distances. However, without the presence of air or a medium to carry sound, astronauts do not experience sound in the same way as they do on Earth. The Milky Way, our home galaxy, is a vast and awe-inspiring collection of stars, gas, dust, and planets. One remarkable fact about the Milky Way is that it contains more planets than there are stars. Stars are the primary constituents of galaxies, including the Milky Way. They are massive, luminous spheres of hot gas that emit light and heat due to nuclear fusion reactions in their cores. Planets, on the other hand, are smaller celestial bodies that do not produce their own light but instead reflect the light of their parent star. The reason there are more planets than stars in the Milky Way lies in the way planetary systems form around stars. When a star forms from a cloud of gas and dust, A surrounding protoplanetary disk forms as well. This disk contains material that clumps together to create planets. Some stars, particularly low-mass stars like our Sun, can have multiple planets in their planetary systems. Thanks to advanced telescopes and detection techniques, scientists have identified thousands of exoplanets, and it is estimated that there are billions of planets in the Milky Way alone. The diversity of exoplanets is astounding. They come in various sizes, compositions, and orbits. Some may be rocky like Earth, while others could be gas giants like Jupiter or Neptune. The discovery of potentially habitable exoplanets, where conditions might allow for liquid water and, potentially, life, has sparked intense interest and excitement in the search for extraterrestrial life. In the distant future, an extraordinary cosmic event is destined to unfold. The Milky Way, our home galaxy, will collide with the Andromeda galaxy, our largest galactic neighbor. This spectacular collision has been predicted by astronomers and is one of the most anticipated events in the future of our universe. The Milky Way and Andromeda are both large spiral galaxies, each containing hundreds of billions of stars. Despite their immense size, galaxies are mostly empty space, with vast distances separating individual stars. When they collide, the chances of actual stars colliding are incredibly slim, but the gravitational interactions between the two galaxies will be dramatic. The collision is expected to occur in about 4 billion years, so it is a long-term cosmic event. As the galaxies approach each other, their mutual gravitational attraction will pull them closer together. As they pass through each other, the gas, dust, and stars in both galaxies will interact, leading to the creation of new structures and possibly triggering the formation of new stars. During the merger process, the two galaxies will become gravitationally bound, eventually coalescing into a single, larger elliptical galaxy. This new galaxy, often referred to as Milky. Despite the immense scale of this cosmic collision, the distances between stars are so vast that direct collisions between stars are unlikely. Instead, the gravitational interactions will significantly alter the shapes and structures of both galaxies. When we gaze at the sun in the sky, we are not seeing it in real time. Instead, we are witnessing the sunlight that left the sun about 8 minutes ago. This fascinating phenomenon is due to the vast distance between the sun and Earth. The sun is approximately 150 million kilometers away from Earth. Light travels at an incredible speed of about 299,792 kilometers per second. Despite this incredible speed, the sheer distance between the sun and Earth means that it takes approximately 8 minutes for light to travel from the sun to our planet. This delay in the arrival of sunlight has intriguing implications for our daily lives. When we watch a sunrise or a sunset, we are actually seeing the sun as it was a few minutes earlier. Similarly, when we observe solar events like solar flares or coronal mass ejections, we are seeing these phenomena as they happened minutes ago. The concept of the finite speed of light and the time it takes for light to travel across space is fundamental to our understanding of the cosmos. It means that the further we look out into the universe, the further back in time we are observing, as light from distant stars and galaxies can take thousands, millions, or even billions of years to reach us. The age of the universe is a fundamental question in cosmology, and current scientific estimates suggest that it is approximately 13.8 billion years old. This age is based on extensive observations, data from various astronomical instruments, and the study of the cosmic microwave background radiation. The concept of the universe's age is intricately connected to the Big Bang theory, which is the prevailing scientific explanation for the origin of the cosmos. According to this theory, the universe began as a singularity, a point of infinite density and temperature, approximately 13.8 billion years ago. In the first moments of the Big Bang, the universe rapidly expanded and cooled, leading to the formation of elementary particles, protons, neutrons, and electrons. As it continued to expand and cool, matter began to clump together under the force of gravity, eventually giving rise to galaxies, stars, and planets. The ability to estimate the age of the universe is a remarkable achievement of modern astrophysics, and it has profound implications for our understanding of the cosmos. It allows us to trace the history of the universe back to its infancy and learn about the conditions in the early universe, the formation of galaxies, and the evolution of celestial structures over billions of years. These curiosities are just a small sample of the wonders and mysteries that the universe holds. Each new discovery in space brings us closer to unraveling the profound secrets of the cosmos and reminds us of how incredible and vast the universe we inhabit truly is. Thank you for being a part of our journey. Subscribe now and let's explore the world and beyond together.